Yes, sir. So good afternoon, everyone. Today let us try to discuss the JEE mains exam that has been conducted on 24th June. Second shift. So we are trying to discuss JEE mains paper that was held on 24th June second shift. So we are trying to cover all physics problems. So basically there are 20 multiple choice questions and 10 fill in the blanks. So these have been covered from almost all topics. So if you try to look at the paper, we can make out that this JEE mains paper resembles or is similar to or taken from NCERT textbooks. Like 60 to 65% paper you can find in resemblance with NCERT textbooks. If you try to look for NEET, you can find around 85% has been taken from NCERT textbooks. Like not exactly taken, but similar problems, similar concepts are being repeated. So for mains it is around 65, for NEET it will be around 85. So take care that NCERT is mandatory for JEE mains. So now let us try to look at the first question. So it's a multiple choice question. So the given question is, identify the pair of physical quantities that have same dimensions. So it's obviously an easy question, but let's try to cover the basics as well. We are not just trying to solve, but also cover the important concepts behind each problem. So first question, A. So what are the units of velocity gradient? du by dy. So where do we get this du by dy? We get this in shear stress, Newton's law of viscosity, where F is equal to mu A du by dy. So generally we get it from there. So its units are meter per second into 1 by meter is equal to second inverse. So how about decay constant? Where do we get this decay constant? This decay constant we get in radioactive decay. So the units of decay constant is again one by second, that is second inverse. So from this we can make out that option 1 is correct. Even let's try to look at the other options. So what are the units of Wien's constant? So units of Wien's constant is meter per Kelvin, and the units of Stephen constant, it is watt per meter square Kelvin power 4. So we can make out that those two don't have same dimensions. And how about this angular frequency radians per second? So we can get as radians per second. Then how about this angular momentum? This is nothing but I omega. So I omega. So how do we make this I is equal to m r square. So L square omega radians per second. We can make out that there it is not the option. Then how about this wave number? The wave number have the dimension of 1 by meter, and the Avogadro number mole inverse. So what is Avogadro number? 6.023 into 10 power 23 number of particles per mole. So mole inverse, this will be meter inverse. So if you try to look at the options given, so we can make out that A has same units, B has different, C has different. So we can eliminate B, C different, D also different. So A is only the option, so we can, so it's an easy question, direct question, but as said earlier, we are trying to cover the important concepts as well. So that's how we need to solve the question. Next. So here the question says that the distance between the sun and the earth is r. The duration of the year if the distance between the earth and the sun becomes 3r. So to which topic does this question belong to? If you try to look at this, belongs to the chapter of gravitation. So how do we solve this? So good morning everyone. So people on live, yes, we are trying to discuss 24th June second shift. So do comment your answers if you have any doubts in it. So we are not just on trying to discuss the answer, also cover the basic concepts behind them as well. So 24th June second shift paper is being discussed. So to which topic does this question belong to? Is belong to law of gravitation. So Kepler laws to be applied, right? So Kepler laws to be actually, I guess question is bit incomplete. The options are not given, right? Option A and option D. Okay, let's try to fill the question. Okay, so it is √3 years and this is 3√3 years. So as people could not type, 3√3 years. So these are the options. So Kepler laws are to be applied. So which law do you think can be applied? Yes, Mr. Yashwant, Kepler third law can be applied here. So what is Kepler third law? What is Kepler third law? Please reply on the chat box. So what is being said? There is sun and earth. The distance between the sun and earth is r. The duration of the year if the distance between sun and earth becomes 3r. So Kepler's laws to be applied. So Kepler's third law is applicable here. So what is Kepler third law? People in the chat box, come on, try to reply. So Kepler third law says that T square is proportional to time period. The square of time period is proportional to the distance between cube of the distance between two objects. So here it is being asked. So T can be written as 3/2. So from that we can directly make out simple question, easy question. So T1 by T2 is equal to R1 power 3/2 by R2 power 3/2. So what is R1? R. What is R2? 3R whole power 3/2. So what do we get? 1/3/3/2. So T1 is equal to, when it is R, it is just a year. Okay. So T1 is equal to 1 by T2 is equal to 1/3/3/2. So T2 is equal to 3/3/2. which is nothing but cube root of 3. So here this is Kepler's third law. We just applied it and substituted it. We got this answer. So the option is D. Yes, Mr. Syed. Come on, people watching online, try to comment your doubts or answers. Let's try to discuss them as well. We are trying to discuss 24th June second shift JEE mains physics paper. So now let's try to look at third question, okay? Right. A stone of mass m so here it is given that a stone of mass m is tied to a string and is being whirled in a vertical circle with a uniform speed. The tension in the string is, and 4 options are given. So it's again a direct question from motion in a vertical circle. So we can directly mark it, but let's try to discuss the concept behind it as well, so that it will be helpful to do similar types of problems as well if you get on these concepts, okay? So what exactly is being said is that it is made to move in a circular path, okay? So a stone of mass m is tied to a string is being whirled in a vertical circle with a uniform speed. The tension in the string is, okay. So the tension in the string, so if you try to look at the free body diagram, it will be T, it will be mg. So as it is moving in a circular path, we have mv square by r. So the tension at the bottommost point is T is equal to mv square by r plus mg, right? So if you say similarly, if you try to look at the topmost point, the tension mg, tension T, it is mv square by r. So the tension at the topmost point is equal to mv by r minus mg. So the question is that what is the maximum? The question says that the tension in the string is, option A is same throughout, no. Option B, minimum at the highest position. Option C, minimum at the lowest position. Option D, the minimum when the rope is horizontal. So in horizontal there is no point of discussing. So the critical points are the top and the bottom. So we can clearly make out that at the topmost point the tension is minus and the bottom it is plus. So at the topmost point the tension is minimum at the highest path of circular motion, okay? B, the minimum is at the highest point of the circular path. So option B. Direct question, simple question, you can easily make out. So see, the questions are of bit low standard. This question is a bit low standard. So let's try to look at other questions as well. So question 4. So come on, people watching online, comment your answers. Comment your answers, okay? So Bhanu Prakash explain Kepler's first law and second law. So go see the area covered along the path traveled by the body in equal times will be equal areas are covered in equal time intervals. So that belongs to the second law. So how about the first law? Please comment, okay? See, okay. So let us complete the paper first and try to get back if time remains, okay? So we are not just, let us not try to lag. So okay, now let's try to discuss the fourth question. Okay. So two masses, two identical charged particles, each having a mass of 10 grams and charge 2 into 10 power minus 7 coulombs, are placed on a horizontal table with a separation distance of L between them such that they stay on in limited equilibrium. If the coefficient of friction between each particle on the table is 0.25, then find the value of L. See, it's again a question of friction and electrostatics in combination. See, the concepts are being mixed. You cannot blindly leave concepts. Some people believe that they can leave some chapters and score good marks. See, the concepts are being mixed, so there is no point in leaving any concepts. Minimum, you need to be aware of complete syllabus. You need to be aware of complete syllabus. Like minimum knowledge is mandatory because inter-conceptual questions are being asked. So people online, try to comment your answers. So if you have any doubts, please share. So yes, Mr. Chakradhar. Okay, Satya Prasad, definitely the sessions will be going on. Today we are explaining shift 2, shift 1, every shift will be covered. So no worries. So we are starting from 24th June, second shift. So try to comment. So how do you go ahead? See, two charges which are at a distance of L. Right? I guess it is L. Right, L. Q. The coefficient of friction between them is mu. So what happens? See, the friction acts in opposite direction of relative motion. So let us consider this as force on charge Q. The friction acts in opposite direction. If they are of opposite charges, if they are of same charges, they repel, right? So you can take the other way around. So let us consider both are of same charge, like both are positive, so they repel. So F due to electrostatic, and it is Fs static friction. Static friction. So we are so this body, this is in equilibrium right now. So if we can equate these two forces, we are done. So what is this force? Force due to electric static field K Q1 Q2 by L square, right? What is this Fs? How do you write this Fs? Fs as mu n, right? So try to equate them. You are done. So let us try to equate them. So what is Fs? It is 0.25 given N mg, m into 10. What is this Fe, force due to electrostatic force? K, 9 into 10 power 9. K, Q1, Q2. Let's see the value again by L square. Let's try to equate them. So what is this? What is the charge? Mass is 10 grams, charge is 2 into 10 power minus 1, right? Mass is 10 grams. So mass is 10 grams. So let us try to convert it into kg, right? Because we are dealing with MKS units. 2 into 10 power minus 7, I guess. Let us check again. So it is 0.1 by 4 is equal to 9 into 10 power 9. 4 into 10 power minus 14 by L square. So I guess mass 10 grams, 2 into 10 power minus 7, right? Yes. So equate them. What do we get? We need to find L square, right? So equate them. L square is equal to 9 goes there, 36 into 10 power 9 into 4 into 10 power minus 14 by 0.1. So if you try to look at this, it will be 36 into 4, 144, right? 6 4 24, 4 3 12, 13 14, right? 144 into 10 power minus 6. Minus 6, huh? How much do you get? So this is 10 power minus 5 into 10 minus 4. So 144 into 10 power minus 4 L square. L is equal to 12 centimeters. Square under root of 144, 12, right? Right. So that's how we will be proceeding this question. So hope it is clear with everyone. So people watching online, comment your doubts, share your answers. If you have any queries, do share them. Let's discuss, okay? So this is basic fundamental question. This is multi-conceptual question where concept of friction and electric field or electrostatic force is being involved, okay? Now let's look at next question. See, the Carnot engine takes 5000 kilocalories of heat from a reservoir. Let us consider it as a reservoir. It has heat engine. So a Carnot engine takes 5000 kilocalories of heat from a reservoir at 727. 727, if you try to convert into Kelvin, it is 1000. So 1000 Kelvin, 127. 127 plus 273, 400. 400 Kelvin. So the work done is being asked. See, direct formula question. No need to use your critical brain or so-called critical. So this is direct question. So Q in into efficiency, right? So what is Q in? 5000 into 1 minus T2, 4 by 10. So it will be So what do we get? We get 3000 kilocalories. See the options, there is 3000 present, 3 into 10 power 6, 3 into 10 power 6 calories. See 3 into 10 power 6, 3 into 10 power 6, but here it is joules. We got in calories. See, that is the reason he gave it in option A. See, if you don't consider or if you don't take care of units, you are gone. All this effort that you have put in will go in vain. So units are very careful. So he gave it as option A to deceive you. So we need to convert that into joules. Okay, 1 calorie is equal to 4.2 joules. So you will be getting 3 into 10 power 6 into 4.2 is equal to 12.6 into 10 power 6 joules. So see the importance of units, how important they are. So definitely Rajesh will provide once the paper is out, so no worries. So the answer is 12 into 10 power 6. So stay connected with Roots Academy, like the session, share the session, okay? So no worries, we will take care of you. So the answer is 12 into 10 power 12.6 into 10 power 6. So units are very important. So don't get carried away by the easiness of the question. So now let's try to look at the next question. Two massless springs with spring constant 2K and 2K carry 50 grams and 100 grams masses at their free ends. These two masses oscillate vertically such that their maximum velocities are equal. Then the ratio of the respective amplitudes will be. So the given condition, two springs. Two massless springs with spring constant 2K carry 50 and 100 grams. 100 grams at their free ends. These two masses oscillate vertically such that their maximum velocities are equal. So how do we equate maximum? So their maximum velocities are equal. We know that displacement is equal to amplitude sine omega t plus or minus phi if there is some sort of phase or something. So what is velocity? A omega integral sine theta cos theta. So minus omega t plus phi. So the Vmax is nothing but A omega. So maximum velocities of both the springs are equal. So what is this omega? Omega, how do we write omega? Omega is equal to under root k by m. Omega is equal to under root k by m. So what do we get here? Under root 2k by 50. Here under root 2k by 100. So the question being asked is, what is the ratio of the respective amplitudes? So now let us equate their maximum velocities. A1 omega 1 is equal to A2 omega 2. So the ratio of their amplitudes is being asked. A1 by A2 is equal to omega 2 by omega 1. So under root, what is omega 2? 2k by 100, right? What is omega 1? Under root 2k by 50. So hi, hello, come on. So people online. So definitely MSET paper that is being conducted will be discussed. So no worries. Let's try to do this mains paper. So once we get authentic information from different sources, we will try to make it as a PPT and we will try to explain the questions. So no worries. So the answer that, so what do you get? So what do you get? So okay, people online. I guess the question is bit wrong. It is 2K and 9K. Okay. So here it is 2K and 9K. That is the reason we are getting wrong. 2K and 9K. 2 and 9, okay. So this is 9, not 2. So one is 2K, the other is 9K. So we get as 9 by 4, I think, but 3 by 2. So option B. While being converted, I think it has gone wrong somewhere. So it is 3 by 2. Right? So we got 3 by 2. Now let us try to look at the other question. So the question, see, this is direct question, nothing to think much. See, the basic concepts are being asked and tested. So what will be the most suitable combination of 3 resistors, A 2 ohms, B 4 ohms, C 6 ohms, such that their equivalent resistance is 22 by 3 ohms. So how do you do it? So basically you can check through options, but if you try to look at the question, the R equivalent is 22 by 3, right? So the denominator gives us 3. So what resistors when connected in parallel give us denominator 3? So if you can try that way, you can reach the answer bit faster. Else you need to check option A, option B, option C, option D. So let's see what is equivalent of A and B when connected in parallel. R1, R2 by R1 plus R2. So A 2 ohms, B 4 ohms, C 6 ohms. So the R equivalent is 22 by 3. See, one way is just check all options. The other way, if you try to approach or reach the answer sooner, here R equivalent is denominator gives us 3. So when do we get fraction? Generally we get fraction when we connected things in parallel. So when connected in parallel, which two when connected in parallel gives denominator 3? Let's try to check for A and B. So R1 R2 by R1 plus R2. So 4 to the 8. 8 by 4 plus 2, 6. 2 by 3. So we are getting denominator here. So let's try to add. See, no one can do. See, it's a skill actually. With practice you get. So 6. Let's try to keep them in series. So 6 plus 3, 18. So what's the answer? Something like 22 by 3, right? So what do we get? So people, Sorry, it's 4. Sorry, 4, 4, 4. It's 4. 2 4s are 8, right? 2 4s are 8, 2 3s are 6. 18 plus 4, 22 by 3. So when A and B are when A and B are in parallel and C is in series, A 2 ohms, B 4 ohms, C 6 ohms. When this is the case, the R equivalent will be 22 by 3. So people watching online, try to comment your answers. Do share your doubts. So no worries. So we are here to solve any doubts that you have. So this is basic fundamental question. Now let's try to look at the next question. So this is again a theory question. So the question says that soft iron is a suitable material for making an electromagnet. This is because soft iron has dash. See, you need to be aware of properties of soft iron and electromagnet. So what are the properties of soft iron? Soft iron is a ferromagnet. Which has high permeability. Which has very high permeability. So we have C and D. So how about this electromagnet? What are the properties of electromagnet? The properties of electromagnet should be low retentivity. It should energize fastly, and it should magnetize or energize quickly and demagnetize quickly. That's the property of, that is an ideal property of electromagnet, because it should act as a magnet when d phi by dt, rate of change of flux, happens. So low retentivity. So it's a theory question. See option C. You can go for option C. This is basically a theory question, right? So people watching online, share your doubts so that they get discussed. So no worries. So hope you are clear with this, right? So now the question, a proton, deuteron and alpha particle, see, okay, alpha particle with the same kinetic energy enter into a uniform magnetic field at right angle to the magnetic field, the ratio of the radii of their respective circular paths. So as the particles are entering uniform magnetic field at right angles, force gets applied. If they enter the magnetic field parallelly, no force gets applied. So you need to be careful with that. He will twist the question and check the basic concepts. So as we all know, here given conditions is that they have same kinetic energy, right? Same kinetic energy. K1 is equal to K2 is equal to K3. So this is a given condition. So first let us try to look at the properties of proton. Proton, deuteron, and the other is alpha particle, right? Let us try to know about their mass and charge. So the mass of proton is 1. Charge is also a single unit. The mass of deuteron 2. Charge single unit. The mass of proton, sorry, mass of alpha particle 4, charge 2 units. Okay, Satya Prasad, definitely will try to discuss on that as well. See, once we get information about the set 1, we will be talking about set 2. So stay connected, stay updated. So we haven't got any authentic information as such. So once we get authentic information, we will share you. No worries. So here it is said that it has equal kinetic energy, right? So when a charged particle is moving in a magnetic field, what is this radius? Radius is equal to mv by bq, right? Right? So here it is said that kinetic energy is same. Kinetic energy is equal to half mv square. Half mv square, 2k by m, v is equal to under root 2k by m. So let us try to substitute v is equal to 2k by m. It will be 2mk k by bq is equal to radius r. So the radius in terms of kinetic energy. So we are now with the variables that we know. Mass, we know the ratios, kinetic energy same, b constant throughout, q. So the question is, what is the ratio of the radii in circular paths? Okay. So r is equal to under root 2m k by bq. So this is of m1 q1 under root of, this is of proton. Okay, proton. This is of proton. So this is of deuteron. And again this is of alpha particle. Alpha particle. So remaining everything goes off because b is constant. Okay, so this is for numerator, this is for numerator. Okay. So mass of proton 1 unit, 1 by charge 1 unit. All right. Is to, sorry. So what is mass of deuteron? It is 2 times, right? 2 root 2 charge 1. What is this mass of alpha particle? Root 4 by charge is twice. So what do we get? 1 is to root 2 is to 1. So the options 1 is to root 2 is to 1, D. Definitely, Mr. Satya Prasad. Actually, we have seen a question just before about the ball rotating in a vertical circle, the tension, maximum tension. So it's basically MSET concept question. You can expect such questions in MSET as well. So definitely this discussion is really important for any competitive exams that you write, okay? So try to do. So those who haven't belong to this session, try to solve. So those who belong to this session, try to clarify whether, try to clarify your doubts, okay? So I guess it is 1:√2:1, right? Okay. So now let's try to discuss next question. What is this next question? So I guess it is hypermeability. We are done with this, right? Is this the 10th one? Okay, I guess the questions got bit misplaced, okay? This is not the 10th one. Let's get back, okay? Let's try to solve the first questions. So the potential energy as a function of R is given by U is equal to A by R power 10 minus B by R power 5. So where R is the interatomic distance, A and B are positive constants, the equilibrium distance between the two atoms will be dash. So the potential energy is given. So it is said that they are at equilibrium. The equilibrium distance is being asked. So when does a system will be in equilibrium? So when the net force on it is 0. Okay. So when the net force on a system is 0, you can say that it is in equilibrium. So using potential energy, how do you calculate the force? Nothing but rate of change of potential energy with respect to R. Gives us the F net. So it is nothing but A by R power 10 B by R power 5, right? A by R power 10 minus B by R power 5. So come on, try to differentiate and find the relation between A and B. Is equal to 0. So try to differentiate. What do you get when we differentiate R power 10? A as constant. So R power minus 11, R power minus 10 by R power 11, right? Plus this negative symbol got into it, okay? So it will become plus 5b R power 6 is equal to 0. So 5b R power 6 is equal to 10a R power 11. Okay. So what is the difference? Phi b by 10a is equal to 1 by R power 5. 6 4 10, 6 plus 5 11, right? So R power R is equal to 10a by 5b whole power 1 by 5. Nothing but 2a by b 1 bar 5. So definitely Saket will definitely try to do the analysis on today's MSET paper. So once we get authentic information, we'll start it. So as we have official paper of this mains, we are trying to solve it. So no worries, stay connected, stay updated. I guess it is, we have option as well. 2a by b, I guess it is C. So option C, 2a by b. So let's try to do the next question. So a body of mass 5 kg is thrown vertically upwards from ground. The air resistance produces a constant retarding force of 10 newtons throughout the motion. The ratio of time of ascent to time of descent will be dash. See, this question is again from kinematics. So how do you solve this? So generally we neglect the friction or the air resistance. Generally we neglect the air resistance. Here he is asking us to take air resistance. So when we neglect air resistance, the force of gravity or net force acting when a body thrown up will remain constant throughout the motion. It will be equal to mg. But here we have air resistance. So it cannot be same throughout the motion. While moving up, so we have two cases here. Case 1, a body is moving up. So when thrown up, there will be mg down as well as friction resistance or air resistance. So the net force acting while moving up, mg down, air resistance down. Case 2, while moving down, mg fr. So while moving down, the property of resistance is to just oppose the motion, whatever direction might it be. So here the net force F net, here the F net will be mg plus fr. Here the F net mg minus fr. See, when we neglect air resistance, net force will be same throughout the motion. But here air resistance need to be considered. We take and we get different F nets while moving up and down. So while moving up, what is this F net? F net mg plus fr. mg 5 kg, right? 50 plus fr 10 60. So while moving down, F net mg minus fr 50 minus 10 40. What is the acceleration? 60 by mass 5 12. What is the acceleration? 40 by mass 8. See, acceleration while going up is different and acceleration while coming down is different. Mr. Abhinandan, definitely MSET will be discussed See, we are waiting for the authentic information. So we are trying to cover as many possible questions as possible. See, even mains is not something that is different from MSET, okay? You have a good 40 to 50% of similar questions that are being repeated in both MSET and mains. So if you are a serious aspirant, you are supposed to know these things, okay? So we got different accelerations, that is, while going up it is 12 and while coming down it is 8. See, from basic fundamentals, the time of ascent or descent is equal to under root 2h by a, which time period is inversely proportional to root a. See, you can derive or get to this equation using kinematics of motion, or you can use some other equations to get to this relation, but this is basically a shortcut. So if you try to use this directly, so time of flight or descent is inversely proportional to square root of their acceleration. So time of ascent by time of descent is equal to under root of accelerations 12 by 8 under root 2 by 3. I guess we have this option. Let's check. So root 2 by root 3. See the resistance, see the role of resistance. So people watching online, comment if you have any doubts. So we got root 2 by root 3. So hope this is clear. Let's try to look at the other question. A flywheel is accelerated uniformly from rest and rotates through 5 radians in first second, and angle rotated by the flywheel in the next second will be dash. So basic question on kinematics once again. See, from omega initial is given as 0 from rest, rotates through an angle of 5 degrees in the first second, which means that omega after first second is equal to 5 radians per second. Okay, what is that being asked? The angle rotated by the flywheel in the next second. So if you try to apply basic kinematics of motion, u is equal to v plus at plus alpha t. So we are trying to find alpha here. Omega final 5 plus alpha time t 1 second. So not this way. So check. So this is one equation we have. Theta is equal to ut plus half alpha t square. So it is given as 5 radians in first second, right? So it is final is equal to initial plus t. Theta in first second is equal to 5 radians. So let us not try to jump. Let us go step by step. Okay. Theta is equal to 5 radians is equal to 1 by 2 alpha time t is 1. Right? T square. So we get alpha as 10. So we got alpha. Find the angle rotated in the next second. So let us try to find the angle in second. Ut initial 0 plus half alpha t square. T is 2 seconds. So after 2 seconds, theta is 20. After 1 second, theta is 5. So the question is the angle rotated by the flywheel in the next second. So from 1 to 2, from first second to second second, the angle rotated will be theta 2 minus theta 1. That is 20 minus 5. That is equal to 15. Basic fundamental simple question. So people watching online, try to comment your doubts. Let's try to discuss them as well. So now let's try to look at the other question. A 100 grams of iron nail is hit by 1.5 kg of hammer striking at a velocity of 60 meters per second. So what will be the rise of the temperature if 1/4 of the energy goes into heating the nail? So actually it is 16.07 option, not 160, it is 16.07. So half of 1/4 of kinetic energy. One-fourth of kinetic energy is used to mc delta t. Direct question, straightforward question. 100 grams. See what is the temperature? The rise in delta t is being asked. M. So what do we get? V square by 8. C, what is the value of C? 0.42. Delta T. So what is the V? 60 meters, right? So 3600 by 8 by 0.42. So this is not of same mass, sorry, different masses, right? So we cannot cancel out. Sorry, I thought they were of same masses. This is 1.5. This is of 100 grams. Here even it is given in joules per gram, right? So we can write it as 100. So what do we get here? 42 into delta T mv square, that is 1.5. V square by 8 is equal to 42 into delta T. So 1.5 V square by 8 is equal to, this is 42 into 8. So if you try to solve it, you get 16.07 per degree centigrade. Okay, Vijay Lakshmi, we are actually waiting for the authentic source, authentic information. So till then we are trying to discuss this so that even this will be helpful to people, because questions are being repeated in both exams. So try to solve this. Okay, so 14th we are done. 15th, see, if the charge on the capacitor is increased by 2 coulombs, then the energy stored increases by 44%. The original charge on the capacitor is dash. See the energy stored in a capacitor, U is equal to half CV square, right? So what do we know? Q is equal to CV. So replace C by QV or V by QC. Q square by C square. So Q square by 2C. U. C is always remains constant. Q. So the energy stored in it increases by 44%. So U is proportional to Q square. So he's saying that the energy increases by 44%. So 1.44 U is proportional to 1.44. I'm just trying to multiply Q square. 1.44 on both sides. So what does it lead to? 1.44 U is equal to 1.2 Q whole square, right? I guess I can write this way. Right? Not equal to, proportional to. Right? So from given question, it is said that increased by 2 coulombs, right? So 2 coulombs is equal to 0.2 Q. Because my final charge is 1.2 and here there it is being said that it is increased by 2 coulombs. So if I try to write it in a more elaborate way, 1.2 Q is equal to Q plus 2. That is what given in question. Q plus 2 is given in question, and from this we got it as 1.2 Q. So which is nothing but 0.2 Q is equal to 2. So Q is equal to 10. So the original charge in the capacitor will get as 10. See the beauty. If you are aware of this, you are done. So first write the equation, convert it into Q, use the relation and apply the logic, you are done. Okay, few people are saying that today's paper is moderate, not tough. So okay, I guess it's a good sign. So once we get the authentic information, definitely we'll discuss the question paper. So stay connected. So do like the session, share the session so that many get benefited. See, as we are providing it for free, your likes really motivate us and helps us to do more such videos. So encourage us. So next question. A long cylinder volume contains a uniformly distributed charge of density rho. The radius of cylinder volume is r. The charge particle q that revolves around the cylinder in a circular path. The kinetic energy of particle. See, a long cylinder volume contains a uniformly distributed charge of density rho. The radius of the cylindrical volume is r. The charge particle q revolves around the cylinder. So for it to revolve around the cylinder, so how do you solve this? So people watching online, try to comment your answers. So how do you solve this? So a charge is revolving around the positively charged cylindrical volume. So we need to consider it as the charge revolving as negative, so that the force of attraction acts as centripetal force. So this is minus q. We need to consider it as minus q. So F is equal to EQ, which is equal to mv square by r. So we need some force so that it should act as centripetal force, right? So we need to consider it as negative and this as positive. So the force of attraction will be towards the center. So that acts as centripetal force and is equal to mv square by r. So what is E? The question is, what is E? If we are, so if we have a standard notation for E. We have standard notation for E when electric field is given. So what is that? Come on, people in the chat box. So it is, so what do we have? mv square by r is equal to EQ, right? mv square by r is equal to, what is that? Rho r square by 2 epsilon naught r. This is the standard notation that we can derive electric field into Q. So from this, so what is he trying to ask? The kinetic energy of the particle. So this is the equation that we have. So r, we can remove r, right? So if you multiply this with half, we are done. So half mv square is equal to, so multiply both sides by half, so that we get kinetic energy is equal to Ke is equal to rho r square by 4 epsilon naught into Q. See, where do we have this rho Q r square by 4 epsilon naught? I guess it is A. Right, A. Rho Q r square by. So you need to be aware of the electric field notation when the charge density is given and present in the form of cylindrical volume. So this is how we proceed. So Akhil Kumar Satyaprasad, I guess you are wrong for this question. I hope you haven't answered B for this, so this is option A. So now let's try to look at the other question. A electric bulb is rated as, so question is bit missing. So let's check. So what's the question? See, the electric bulb is rated as 17th, right? 200 watts. So what will be the peak magnetic field at a distance? So what will be the peak magnetic field at a distance produced by the radiations coming from this bulb? 70th, okay. What will be the peak magnetic field at a 4-meter distance? Okay. The question is not correct, it's incomplete actually. Consider the bulb as a point source with 3.5 efficiency. Okay, all numericals are missing. 3.5% efficiency. So how do you solve this? So people watching online, come on, comment your answer. See, let us consider it as a source and at a distance of r. What is the intensity? Source of power. What will be the intensity? Intensity is equal to power by 4 pi r square. Right? What is 4 pi r square? This is surface area. So intensity is equal to power by 4 pi r square. So we have a relation between the magnetic field and intensity, that is, we have a relation between magnetic field and intensity, that is I by C is equal to B naught square by 2 mu naught. So hope we have all the notations. So it is B naught by 2 mu naught. So people online, try to comment your answers. So if you try to substitute the values in it, we can easily make out. So check. So try to substitute, find B naught. I guess we have intensity. So B naught is equal to 2 mu naught I by C. So here it is 3.5 efficiency, right? So intensity will be the product of efficiency. Intensity will be power into this into efficiency. So if we try to solve the problem, you will get as 1.7 into 10 power minus 8. Basic calculation. So people online, come on. So a light of two different frequencies whose photons have energies 3.8 electron volts and 1.4 electron volts respectively illuminate a metallic surface whose work function is 0.6 electron volts successively. The ratio of maximum speeds emitted by maximum speeds of emitted electrons for the two frequencies respectively will be dash. See, the energy of incident is 3.8 for one case, and the other case it is 1.4 electron volts. What is work function is given as 0.6 and it is same for both. 0.6 for both. So what exactly is work function? The minimum energy required to remove an electron from the given metal surface, and it's a property of the material. So here he is trying to ask the ratio of maximum speeds. So the remaining energy apart from the 0.6 will be used as kinetic energy. So for case 1, for first case, 3.8 minus 0.6, 3.2. Case 2, 1.4 minus 0.6, 0.8, right? So these are the roughed out energies once the electron comes out. So he's trying to ask the ratio of maximum speeds. So how do you find maximum speeds using this? So that is nothing but kinetic energy, right? That entire energy. So V2 square by V1 square. So as it is both are of electrons, masses will be same, half masses gets cancelled. V1, okay, however you take V1 square by V2 square. V1 3.2 by 0.8. equal to 4 equal to v1 by v2 is equal to 2. Two is to 1. Right? Yes, Akhil Kumar, you are right. Satyaprasad, right. Come on, people watching online, comment your answers. So basic fundamental question. Okay. So two light beams of intensity of ratio 9:4 right are allowed to interfere the ratio of intensity of maximum and minimum. So this is being asked. So come on, people watching online. So we know that it is equal to root I1 plus root I2 minus root I1 minus root I2 whole square. So if you proceed, 3 plus 2 by 3 minus 2 whole square, 25:1. Option D. Come on, people watching online. So direct question, direct formula, nothing much. Okay. So in Bohr's atomic model of hydrogen, let K and P and E are the kinetic energy, potential energy and total energy of the electron respectively. Choose the correct option when the electron undergoes transition to a higher level. See, when electron goes from lower level to higher level, what do you think will happen to potential energy? Potential energy, kinetic energy. So kinetic energy, potential energy, and sum of these two will be equal to total energy. So as the body moves away, what do you think will happen? Kinetic energy decreases because, see, when it is close to the nucleus, the force of attraction will be more and it is compensated by mv square by r. Okay? When you are moving away from the nucleus to higher orbitals, the force of attraction decreases. So it is equal to again mv square by r, so velocity decreases. So kinetic energy decreases. How about potential energy? Potential energy will be in the form of negative terms. So negative. Potential energy at infinity will be 0. Till then it will be in negative terms. So as you move to higher orbits, the magnitude decreases, which means that potential energy increases. Negative magnitude decreases, potential energy increases. So the total energy, the sum of these two energy will increase. So kinetic energy decreases, potential energy increases, and total energy increases. Decrease, P and E increase, I guess B. K decreases, potential and kinetic energy, total energy increases. So let's move to next question. Okay. So we are done with multiple choice questions. Now it's blank, fill in the blanks. A body is projected from a ground at an angle of 45 degrees with horizontal. Okay. So we don't have any options available, so no kind of guessing, checking the options. So we need to know subject to solve such questions. A body is projected from the ground at an angle of 45 degrees with the horizontal. Its velocity after 2 seconds is 20 meters per second. The maximum height reached by the body during the motion is dash, h max. So how do you solve it? So let us consider it as u cos 45, u sin 45. So here the angle will be something, not 45. Okay, don't assume that it will be 45. So how do you solve this? Come on, people watching online. See, whatever it might be, the net force after 2 seconds is 20, right? It is given as 20. So the u cos 45 remains constant throughout the path. So u sin 45 only changes, right? V after 2 seconds, V is equal to u by root 2, V is equal to u plus at, A10 to t. V is equal to u plus at. A is nothing but minus 10. The acceleration due to gravity, t is 2 seconds. I am trying to find vertical component of velocity after 2 seconds. So it will be u by root 2 minus 20. V by 2 seconds. So we know after 2 seconds the horizontal component remains same, that is u root 2. U by root 2. We know the horizontal component, we know the vertical component, and we know the magnitude. So using the vector law of addition, we can find it, right? Let's see. See, we know the magnitude as 2, right? Under root of Vx square plus Vy square plus 2V1 cos 90. So if you try to solve this, the angle between them is 90, right? So 0. So Vx square. What is Vx square? U by root 2 whole square plus Vy square. U by root 2 minus 20 whole square, I guess. Let's check. U by root 2 minus 20. Velocity in y component, x component, u by root 2 is equal to, this is 20, right? Yes, this is 20. Its velocity after 2 seconds is 20. So this is 20. Now let's square. Basic mathematics, you are done. A square minus 2ab by plus b square. Okay, 400 out. U square becomes u square. If you try to go there, 40 u by root 2, right? 22 is 40, 40 u by root 2, u square by 2, u square by 2, u square. So u cancel. So u is equal to something as 40 by root 2. Do we have such answer? What is being asked? So the question is not velocity. He is asking the maximum height reached. So we got u, nothing but the initial velocity with which the body has been thrown. So h max u square sin square theta by 2g. We got u as 40 by root 2, 40 by root 2 whole square sin square theta 1 by 2 sin 45 root 2, right, by 20. So how much do you get? 4 for the 1600 by 2 into 1 by 20. 2 is a 4, 4 for the 16, 20. Sorry, 20. What is maximum height reaches? 20 meters. Sorry. I guess we are. Yes, maximum height is 20 meters. Right? So we got velocity with which thrown is 40 by root 2, and h max we got it as 20 meters. So people watching online, so Miss Satvika, nothing to worry. So I guess you have put your efforts. So in the last minute, staying calm will does great job. So nothing to worry. So in the last minute, you hardly can do anything. So just try to revise the formulas. Stay calm. You will do well. So no worries. Okay. So you can try to look at the tips given in the Root Academy by our math sir. So you can go through them. I guess that will help you as well. So staying calm in the last minute will amplify the result. So be cool, stay positive. You will obviously do well. So nothing to worry. So how about next one? So we have question: an antenna is placed in a dielectric medium of dielectric constant 6.25. If the maximum size of the antenna is 5 mm, it can radiate a signal of minimum frequency of dash gigahertz, given mu r is equal to 1 for dielectric medium. See, we know the lambda by 4 is equal to the size of antenna. 6 point, what is the, I guess length of antenna is given, right? I guess here they misplaced. Okay, 5 mm. Okay, right. Sorry, 5 mm. So lambda is equal to 20 mm. So lambda is equal to 20 mm. So here it is being asked the frequency of radiation. It can radiate of minimum frequency. So we know that first we need to calculate the velocity, that is equal to c by under root mu r er epsilon naught r. So where c is the velocity of light, 3 into 10 power 8 by mu r is 1 into epsilon r, that is given as dielectric constant, nothing but 6.25. So if we try to simplify this, we get V. So what is the frequency of radiation? F is equal to V by lambda. So we got velocity as 3 into 10 power 8. 3 into 10 power 8 by 6.25, 2.5, right? 2.5 into lambda, 20. So 20 into 10 power minus 3. So we get as 6 into 10 power 6, 10 power 9 hertz. So 6 gigahertz. So direct question, nothing much. Once you are aware of this formula, you are done. You need to be aware of these two formulas, then you are done. So let's try to go to next question. Yes, potentiometer of wire of length and resistance 20 ohms is connected in series with 25 volt battery and an external resistance of 30 ohms. A cell of EMF in secondary circuit is balanced by 250 centimeter long potentiometer wire. The value is x by 10. The value of x is dash. See, here it is being asked a potentiometer wire of length and resistance 20 ohms is connected in of length. I guess length is given. Length questions are typed half. Where is that question? A potentiometer wire of length 10 meters, okay, and a resistance of 20 ohms is connected in series with 20 volt battery and an external source 30 ohms. So right, I guess question is complete now. So it is being said that a battery, so let us go for next page. A potentiometer wire of length 10 meters, resistance 20 ohms is connected in series with a 25 volt battery. 25 volt battery, 10 meters length. This is 8 ohms, 20 ohms, and 30 ohms external. This is 20 ohms. We have 30 ohms external. We have 30 ohms external, right? So this is potentiometer wire. So a potentiometer wire of length 10 meters, resistance 20 ohms is connected in series with 20 volt battery with an external resistance of 30 ohms, and cell of EMF in secondary circuit is balanced by 250 centimeter long potentiometer. The value of EMF is dash. Here he is asking this. So how to solve this? So first let us try to find the current in the circuit. V equal to IR. So I into R1 plus R2, 20 plus 30, 50 is equal to V 25. 25 by 50 is equal to I equal to 0.5, right? So we got I as 0.5. So what is the potential drop across this 250 centimeter length? So first let us try to find the potential drop per length along the potentiometer. So it is V is equal to IR 0.5 into R. What is this R? 20 by 10, right? It is 1 volt per meter. Right, 1 volt per meter. So for 250 centimeters, so for 2.5 meters, it will be 2.5 volts, right? See, it is 1 volt per meter here. It is 2.5 volts for 2.5 centimeter, 2.5 meters, right? So the E will be 2.5 volts. But here the question is E is equal to x by 10. So here he is asking what is the value of x. X is equal to 25. So you need to be aware of all these small things at the end, what is being asked and what you got. So if you try to rush, you will miss the problem, okay? So people try to solve this. So if any doubts, please ask me. So no worries. So let's try to look at next question. So two traveling waves of equal amplitudes and equal frequencies move in opposite direction along a string. They interfere to produce a stationary wave whose equation is given by this. The amplitude of the particle at x is equal to 4 by 3. See, direct straightforward question. See, the amplitude is nothing but y cos pi x. X is equal to 4 by 3. Just substitute. So it's 10, right? 10 cos pi x, 10 cos pi x is equal to 4 by 3. So what do you get? Cos 4 by 3 into 10. So you get it as 5 centimeters. Direct, simple, straightforward question. So we are almost done. We are almost at the end. So next question. In the given circuit, the value of current IL will be dash millivolts. See here, a Zener diode is given which acts in reversed bias condition. So the potential difference across this, the potential difference across these 2 points cannot be greater than 5 volts because it leads to breakdown. So in the given circuit, so if you are aware of this condition, you can easily solve it. In the given circuit, the value of IL will be dash. V equal to IL RL. So V is 5 volts, IL RL 1 kilo ohms. So you need to be very careful with the units. So 5 by 1000 amps is equal to IL. So 5 milliamps. Straightforward question. So if you are aware of the property, you are done. So nothing to worry. Straight question. You can solve it. So people offline, make sure that you don't just copy the question. Solve it as well, okay? So okay, hope it's audible now. So let's try to look at next question. A sample contains 10 power minus 2 kg of two substances A and B with half-life 4 seconds and 8 seconds respectively. The ratio of their atomic weights is of ratio 1:2. The ratio of amounts of A and B after 16 seconds is x by 100. Find the value of x. So how do you solve this? See, we know n is equal to n0 e power minus t capital T. Sorry, minus lambda t. Sorry, e power minus lambda t. So this is a basic fundamental equation that we know. Okay. So from this, here it is said that a sample contains same masses, 2 kg of each, with half-lives T1 by T2 is equal to 4 by 8. Okay. And their atomic weights M1 by M2 is equal to 1:2. 1:2. So then the ratio of atomic weights is given. Then the ratio of amounts of A and B after 16 seconds. After 16 seconds, how do you solve this? So let's try to find a relation. See, using this relation, we cannot directly solve it. So we need to have a relation between small t and capital T. Then we can do it, okay? So how do we do this? See, we know that half is equal to e power minus lambda t, right? Where t is the half-life, okay? And the n by n naught is equal to e power minus lambda t. Actually, the option, the answer for this question in NTA is given wrong. So this is the right answer. So please be careful and check. Okay, from these two equations, we are trying to find, let's equate them. So what do we get? From first equation, ln 2 is by t is equal to lambda. Okay. Okay, let us not jump. Okay, let's try to go step by step. So first let us apply ln to this. Ln n by n naught equal to minus lambda t, right? So lambda is equal to minus ln n by n naught by t. Okay. So same, if you try to apply lambda there, ln 1 by 2 is equal to minus lambda t. So ln 1 by 2 minus is equal to t is equal to lambda. So if you try to equate these two equations, we'll get a relation as n is equal to n naught e power minus t by capital T, where capital T is the half-life, small t is the time at any given time. So capital T is half-life. So from this equation we can solve this question. So the question says that so n1 by n2 is equal to m2 by m1. See what is n1? See here we get n0. n1. See we are trying to apply this n0 01, n0 01 by n0 02 into e power minus t by capital T1 e by minus t by capital T2, right? So what is n01? Initial amount of substance, initial amount of second substance, amount of first substance after time t, amount of second substance after time t. So how do you write n01? N01 and the number of moles given weight by molecular weight, given weight by molecular weight into Avogadro number. N01 is equal to, and N02 in the similar fashion, given weight by molecular weight into Avogadro number. So if you try to substitute there, so what do you get? N1 by N2 is equal to M2 by M1 2 power minus T1 by T1 plus 1 by T2. See, n0 substituted here, n0 to substituted here, e power minus t by 2 goes up, it becomes plus t by capital T2, so minus t taken out. So if you try to substitute, we know T1 given 4 seconds, half-life, T2 given 8 seconds, okay, M2 by M1, it is 2:1, okay. So after time t 16 seconds, what is the ratio of N1 by N2? So the question that is being asked is the amounts of N1 by N2, right? Okay. N1 by N2 is equal to 2:1, 2 power minus 16 after time 16 seconds, okay, 1 by 4 minus 1 by 8, I guess. Check. T1 4 seconds, T2 8 seconds, okay. Okay. So from this, if you try to solve, you get it as 0.5 N1 by N2, which is equal to x by 100. X is equal to 50. In your NTA, it is given as 25, right? So hope my volume is audible, right? So hope my voice is clear, right? So we are almost done. I guess there is another single problem left. So here your answer in NTA is given as 25. So please check. I guess they will modify their key. So a light ray, a ray of light incident at an angle of 60 degrees on a glass slab. And the glass slab of refractive index mu is equal to √3. After refraction, the light ray emerges out from another parallel phase, and lateral shift between the incident and emergent ray is 5√3. So what exactly will happen? So this is called as lateral shift. So lateral shift is given as 4√3. The thickness of the slab is being asked. So from Snell's law you can make out. Okay. So from Snell's law, if you try to solve, actually we have a direct standard formula, that is L by T is equal to, you can derive this from Snell's law, standard notation sin I minus R by cos R. So how do you find R? First we need to find R. See, mu is equal to sin I by sin R, right? Where R is the angle of refraction, sin I is the angle of incidence. So it is given as √3 mu √3 sin I sin 60 √3 by 2 sin R. So R is equal to 30 degrees. So R is equal to 30, I you have 60, we have all these. We have lateral shift 4/3 and find thickness. Thickness you get as 12 centimeters. Thickness of this slab. So a circular coil of 1000 turns each with an area of 1 meter square is rotated about its vertical diameter. The rate of 1 revolution per second in a uniform horizontal magnetic field is 0.07 Tesla. The maximum voltage generated will be. See, N is 1000. Area is 1 meter square. B is 0.07. So this is a straight question, straight direct formula. EMF generated is equal to N B A omega. If you substitute N 1000, B 0.07, area 1 meter square, omega. What is this omega? 1 revolution per second. Omega is equal to 2 pi. So we get as 440 volts, straight formula. See, basic fundamental questions are asked. So do like, share the session if you want more such paper discussions. We are trying to discuss all papers. So your likes really motivate us. So a monatomic gas performs the work of Q/4, where Q is the heat supply to it and the molar heat capacity of the gas will be dash R during the transformation, where R is the gas constant. See, we know from the first law of thermodynamics, heat supplied is equal to change in internal energy plus work done. So gamma for monoatomic gas 1.67. Okay. So here it is said that Q/4 delta U plus work done. Sorry, this is Q, this is Q/4. So delta U is equal to 3Q/4. So delta U is equal to 3Q/4, right? Okay. So delta U and CV delta T, right? So 3Q/4 is equal to number of moles 1, CV for monatomic gas 3R/2 delta T. Okay. So how do you solve still? So what is being asked? The heat capacity. We can also write Q as NC delta T. So if you try to write Q is equal to 2R delta T from here, right? 2R delta T. So we have NCV delta T. If you try to compare these two, where N is 1, so C is nothing but 2R. So the answer for this is 2R. See, here we got change in internal energy. Change in internal energy is equal to NCV delta T or NC delta T. See, this is NCV delta T delta T. Q heat supplied is equal to NC delta T. We are trying to find Q from this and comparing them. We get C as 2R, where C is the molar heat capacity of gas. So the last question. So here it is given that experiment to verify the Newton's law of cooling. A graph is plotted between temperature and water surrounding as time shown in the figure. The initial temperature of water is taken as 80 degrees. The value of T2 as mentioned in the graph will be. So we all know the Newton's law of cooling, that is dt by dt is equal to K theta 1 plus theta 2 by 2 minus theta s. So this is a basic fundamental version of Newton's law of cooling. So if we try to derive, and we have a standard notation where delta t says that, from that if we can derive this Ti, this is a standard notation, Ti minus T naught e power minus kT, where T is the time, sorry. So first, if you try to look from the graph, the first it is 40. So first it is 40, next delta t is 20, okay, and the first t is 6, second t is t2, and Ti minus T naught, what is it? See, initially 80, right? Initial temperature of water is 80, and the difference with the surroundings is 60, which means that temperature of surroundings is 20, right? 80 minus 20, 60. So Ti minus T naught will be 60. So Ti minus T naught will be 60. So if you try to substitute the values, Forty is equal to 60 minus e power minus k into time taken 6. 20 is equal to 60 into e power minus k time taken t2. If you try to solve this for t2, as k is constant, right? 2 by 3 e power minus 6k. So ln 3 by 2 6k, ln 3 is equal to t2 k. So ln 3 by 2 by 6 is equal to ln 3 by t2. So if we solve for this, we get t2 as 16.25 minutes. So this is the last question. So finally we are done. So the answer is 16.25 minutes. So thank you all. So we will try to discuss the remaining shifts as well. So do like, share the session, so that your likes really motivate us. Share the session, and please comment what all you required. Okay, thank you for being patient. And the MSET papers that are being conducted will be discussed once we get the authentic information. Thank you.